Very good morning to all of you. Today we will discuss the remaining types of reactions. So yesterday we had discussed about the addition reaction, substitution reaction, addition reaction. We had discussed electrophilic addition, nucleophilic addition reaction. In substitution reaction, we had discussed about the electrophilic, nucleophilic, and free radical substitution reaction. So here the remaining types of reactions. There are two types of. There we discuss. Here we discuss the one other type. It is the elimination reaction. So actually, what is the elimination? Elimination is actually the elimination of atoms or group of atoms from the carbon atoms from the carbon atoms in a molecule. They will be eliminated from the same carbon atom, or they may be eliminated with the from the different carbon atoms in the carbon atoms in the molecule. For example, alpha elimination. Actually, alpha elimination means when actually hydrogen atom is when hydrogen atom in your higher class you will see actually alpha elimination means when hydrogen atom is replaced from the alpha carbon atom. When hydrogen is eliminated from the alpha carbon atom, then we may say the reaction is called as alpha elimination reaction. You may also write that this alpha elimination reaction is a type of reaction in which hydrogen is replaced from the alpha carbon atom. Clear? So here we will see that it's a dehydrogenation of primary or secondary alcohol with reduced copper at 573 Kelvin. Clear? So actually in this reaction, dehydrogenation of alcohols takes place. So dehydrogenation means loss of hydrogen. So actually the loss of hydrogen takes place in a reaction. So how this loss of hydrogen takes place? So this hydrogen gets lost from this carbon atom. Carbon atom is connected with this OH and this hydrogen. So this actually the one of the hydrogen from this oxygen and this hydrogen gets eliminated. Clear? To form this hydrogen molecule. But if you see here that this called as the alpha carbon, this called as alpha carbon, and this called a beta carbon. So here we'll see that this hydrogen which is adjacent, which is attached to this alpha carbon, it is actually getting replaced. It is actually getting replaced. So that's why it's called as the alpha elimination reaction. Or we may also define in the another term when two atoms or group of atoms are eliminated from the same carbon atom. For example, there are two hydrogen atoms are replaced from the same carbon atom. So this may be also called as elimination reaction. Clear? So there are different driving force for the why these hydrogen atoms and why the two hydrogen atoms they get replaced, or why the dehydrogenation takes place. Actually there are different conditions under which the reaction takes place. Clear? So here this results in the formation of a stable product that's called as the acetaldehyde. Clear? And hydrogen is formed. So here similarly you may take another example. Here we are taking the secondary alcohols. Clear? So in case of secondary alcohols, there's similarly this hydrogen and this hydrogen gets eliminated as in the formation of hydrogen molecule. So there occur a dehydrogenation. So here secondary alcohol gets transformed into acetone. Clear? With the reduced copper at 573 Kelvin. Clear? Similarly, we will discuss here beta elimination reaction. So here in case of beta elimination reaction, you may define it that when hydrogen atoms are eliminated from the beta carbon atom, or you may also define it when two atoms when two atoms or group of atoms are eliminated from the adjacent atom in the molecule. The two hydrogen atoms are for example, these two atoms or group of atoms are eliminated from the adjacent first carbon and second carbon. So this is called the beta elimination. Okay. So actually we may also you may also define it as the hydrogen atom is eliminated from this beta carbon atom. So when the hydrogen gets eliminated from the beta carbon atom, this is called as the beta elimination. Clear? So you may define in either way, whatever you want. So here actually we have taken the reaction dehydration of alcohols in presence of concentrated H2SO4. So dehydration means loss of water, loss of water. So loss of water takes place in presence of concentrated H2SO4. For your confirmation, actually the every reaction have different mechanism. So here if we discuss the mechanism of the reaction, you will see the reaction takes place under the concentrated H2SO4, and that is in presence of a strong acid H2SO4. So H2SO4 being strong acid, it gives proton in the solution, H positive plus HSO4 negative. Clear? This proton will combine with OH this OH negative ion. This results in the formation of an intermediate product, which we will show here. This called as here. I will show here the intermediate product will be the hydrogen gives proton to this and proton to this, and this gives product that will be just like as this carbon hydrogen, and here you will see here that OH will combine with another hydrogen to form the water molecule. Clear? Rest of the hydrogen over here. So this, because this OH, no, it is not the best, it is not a good leaving group, but this water, this is the best leaving group, because oxygen does not bear positive charge. Because oxygen being electronegative does not bear this positive charge, as a result of which it gets eliminated in the form of water. So here the water molecule is formed in the reaction, and because this water during this elimination of this water molecule, this bond gets shifted to this carbon atom in order to stabilize this carbon atom, because due to the release of this water molecule, this carbon gets some positive charge. Clear? So this carbon hydrogen bond gets shifted toward this carbon, and result in the formation of this double bond, that is alkene. Ethylene is formed and alkene is formed, and this hydrogen which is in the reaction condition, this again combines with this hydrogen will combine with HSO4 negative, it gives again into H2SO4. So from hydrogen proton, H2SO4 will use proton in the first reaction, and in the last reaction it abstracts this hydrogen again to form the H2SO4. So in the reaction we have seen that this OH combines with hydrogen to form water. Clear? So here remaining is HSO4 negative. Clear? So secondly, there is a shifting of bond due to this ethylene is formed, that is alkene formed, carbon carbon double bond compound is formed, and this hydrogen combines with this hydrogen HSO4 negative to form the H2SO4. So this is how different reactions have different reaction mechanism. Clear? So in case of this, in case of dehydration of alcohol, you have seen that there occur beta elimination of hydrogen, and beta hydrogen gets eliminated. Clear? You may also say this beta hydrogen, this because this attached to the beta carbon atom. Clear? Similarly is another type of reaction, this called as rearrangement reaction. In rearrangement reaction, what happens there, one one product being less stable, when one structure of the molecule being less stable to that of the another structure of the molecule. जब एक structure unstable होता है as compared to the another structure of the molecule, then there occurs shifting of the atoms or group of atoms. This shifting of atoms or a group of atoms from one position to a new suitable position to form a new rearranged product. Clear? This is called as a rearrangement reaction. That is shifting of, for example, A gets shifted from carbon 1 to carbon 3. Carbon 3. So this shifting occur only under favorable condition. Under favorable condition, that is, the new product is called as rearranged product. Rearranged product. So that is why it is called as a rearrangement reaction. So we have here we have seen just one chlorobutane rearranges to form two chlorobutane. Actually, what happened? It happens that actually there actually this is before formation of one chlorobutane. This is there is a formation of primary carbocation. Primary carbocation just like this CH3, CH2, CH2, positive. As a result of which it gets attached this to form the one chlorobutane. Now it is attached at what carbon? So actually there is one more CH2. Sorry, you may write this. There is a you may write this. It is actually CH3, CH2, CH2. थोड़ा मिसप्लेसमेंट हो गया है. There are only 3 carbon atoms shown. Actually there should be 4. So CH2, CH2, Cl. तो it becomes one chlorobutane. ये one chloroethane ये आता है. तो ये जो है here it is wrong. Actually it is this CH3, CH2, 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 Cl. So it is one first it is attached to first carbon atom, first, second and third and fourth. So it becomes one chlorobutane. So you must write here that here some error takes place. Actually here is CH2 and in there is CH3. CH3. It is not working well. So actually here is the molecule. I will write here again. CH3, CH2, 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 Cl. So write in this place you may write this molecule because it is one chlorobutane. 1, 2, 3, 4. So this is one chlorobutane in presence of AlCl3 at 573 Kelvin. So it gives two chlorobutane. It gives 2 chlorobutane. That's 1, 2, 3, 4. So it gives 2 chlorobutane. Why? Because of the rearrangement. Why the rearrangement takes place? Because this carbon atom will be actually before the formation of this there occur, and this carbon atom will be primary carbocation. The intermediate formed during the formation of this product will be from primary carbocation, but here there is a formation of secondary carbocation. So by releasing, if the chlorine gets released from here, primary carbocation gets formed, but if the chlorine gets released from here, secondary carbocation gets released. So secondary carbocation being more stable to that of primary carbocation, as a result this product is more favorable to that of the first product. So because secondary carbocation is more stable as compared to the primary carbocation. Why it is so? Because we have seen in case of stability of our carbocation, we have seen that the secondary in case tertiary carbocation is even more stable than a secondary carbocation. If there will be such a condition, then there will be the chlorine will be attached to that carbon atom which is tertiary carbocation. So here this carbon is secondary and this carbon is primary. Here will be here will the formation of primary carbocation. Here will the formation of secondary carbocation. So that is why secondary carbocation being more stable due to the inductive effect of two alkyl groups today than that of the primary carbocation where there is only one alkyl group. So here you may write this like that there is only one alkyl group, but here are two alkyl groups, or there are two alkyl groups. Clear? As a result of which, when this chlorine gets eliminated or this gets eliminated, it forms a primary carbocation, it forms a secondary carbocation. The secondary carbocation being more stable than primary carbocation, as a result there occurs shift from this carbon atom to this carbon atom. So actually there are four carbon atoms. It is like this: CH3, CH2, 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 Cl. So shifting of the carbon atom takes place from this carbon atom to this carbon atom. Clear? As a result, you are seeing there is a formation of 2-chlorobutane. Clear? So it is due to the favorability of the product, the secondary carbocation being more stable than primary carbocation, as a result of which this chlorine gets shifted from one position to another more stable position. So this is called the rearrangement of the rearrangement reaction, rearrangement of 1-chlorobutane to 2-chlorobutane. Similarly, you have you are well known about the reaction, because here the ammonium cyanate upon heating rearranges to form urea. Clear? So this actually the reaction takes place here. It was one of the well-known scientists that is called as a Wohler, who was actually preparing ammonium cyanate, an inorganic compound, but due to some chemical reaction, due to some chemical feasibility, there occur rearrangement of the reaction. Due to heat, there occur rearrangement of the product, results in the formation of first organic compound that's called as a यूरिया. तो अगर आपको याद है, मैंने पढ़ाया है कि पहला ऑर्गेनिक कंपाउंड क्या बन गया है, यूरिया, और वो किसने बनाया है, वोलर ने. क्या बनाया, वोलर. बिफोर इट वाज कंसिडर्ड दैट the organic compound cannot be prepared in the laboratory, so it was accidentally prepared from ammonium cyanate due to the rearrangement of atoms. If you see the molecular formula of these two compounds, they have same molecular formula, but their structure is different. So this is due to the rearrangement occurs in these atoms to form the new molecule. This is inorganic compound, but this is organic compound. So this was the first organic compound prepared in the laboratory by Wohler, which was prepared accidentally, because it was before it was considered that that in organic compound there are mysterious forces, so we can't prepare the organic compound in the laboratory. So but this organic compound was the first which was prepared in the laboratory by Wohler, but it was too by accident. Accidentally it was prepared in the laboratory by rearrangement, because there occurred the rearrangement of ammonium cyanate urea. Hope you understand. Share and like करो.